In this video, we're going to be talking about the properties of logs. Now, these properties of logs are going to look very similar to the properties of exponents. The reason why? Once again, a logarithm is an exponent. It's just another way of writing it. Your first property of logarithms is called the product property. If you ever have the log of two things being multiplied, it's a lot like simplifying radicals. You can break them apart. Here's how you're going to break them apart. The log of base b of m times n can be broken into log base b of m plus log base b of n, which is again very similar to how do you multiply x squared times x to the third? What do you do with those exponents? You add them. So to multiply, you add, which again you see in the box is what we're doing. So we're going to work these backwards as well. Well, what if you have a log plus a log? What do you do with that? You multiply them together. And that's what we're going to do here. We're going to condense these logarithms using this rule. A log plus a log. You can condense into a single logarithm by taking the arguments and multiplying them. So that'd be log base 2 of 28. Again, a log plus a log is the log of m times n. Number 2, let's zoom in a little bit. Log 25 plus log of 4 would be the log of 25 times 4, which is 100. Now, I do want to simplify that further. This is a base 10. So if you remember, just to remind you, you're saying 10 to what power is 100? This thing simplifies to 2 if you simplify it even further. Bases are the same here. So you can combine these by doing log base 4 of 2x times 4x squared. And then we can clean that up by doing the log of 8x to the third. And that'd be a base 4. Okay. Number 4, on these we're expanding. We're going to break it apart just to show you. Log of 6, you can, that's the same thing as 2 times 3. So log of 2 times 3 you can write as the log of 2 plus the log of 3. Now as you expand these, your bases, the original base was 10, so therefore your base does not change. The new bases will also be 10 for both of these. Log base 7 of 45, well 45 is 9 times 5. Or you could write it as 3 times 3 times 5. But we'll just leave it as 9 times 5 just to show you that this could be written as a log base 7 of 9 plus the log base 7 of 5. Now what if you've done 3 times 3 times 5? Let's do it now. That'd be log base 7 of 3 plus log base 7 of 3 plus log base 7 of 5. You can write it either way. Log base 2 of 5x is log base 2 of 5 plus log base 2 of x. So what do we need to learn from this? Anytime you have multiplication, it can be broken into two logarithms being added together. Okay, so our next property of logarithms is called the quotient property. Now we just multiplied, and to multiply we added two logarithms together, so you can probably guess. The log base b of m over n, to divide two things, that'd be the log base b of m minus the log base b, let me try again, of n. To divide the log of a quotient, then you'll do the difference between the two logs. So here we're going to condense this into a single log. A log minus a log can be written as a quotient, 24 divided by 8. And we can clean that up. That's 24 divided by 8 would be 3. And you could go a step further. 3 to what power is 3? That's if you wrote it in the other form. You could clean this up all the way to 1. Log base 2 of 15 minus log base 2 of 15. Probably already know what this answer is going to be, but let's go through the long steps. You could write that as log base 2 of 15 over 15, which is log base 2 of 1. Now we're saying 2 to what power is equal to 1? That would be 0. Anything minus itself is equal to 0. That would have been much quicker. And then number 9, log base 4 of x to the 9th minus log base 4 of x squared would be log base 4 of x to the 9th divided by x squared, which again can be cleaned up. Log base 4, 9x's, 2x's leaves you with 7x's. And you can put the parentheses around it or not, either way. Okay, now we're going to expand using the quotient property. Now I know 4, the number 4, There's several ways we could write that. We could write it as 8 divided by 2, 12 divided by 3, 16 divided by 4. Any of these would be fine. We're just showing you a little extra practice on how to use that quotient property. So we'll write it as 8 divided by 4. So that would be, using the quotient property, the log of a quotient would be the log of the top minus the log of the bottom. And you could actually clean this up because log base 8 of 8. Again, 8 to what power is 8? This would be a 1. So you could write this as 1 minus log base 8 of 4 if you'd like to. Log base 5 of 1/3 would be log base 5 of the top minus log base 5 of the bottom. That's, again, what you do with the quotient. And again, this can be cleaned up. Log base 5 of 1 is saying 5 raised to what power is 1? That'd be 0 minus log base 5 of 3. And you don't even have to put that 0 if you don't want to. Number 12, log of m over 7 would be the log of m minus the log of 7. Done. Next up, we have our power property, and that's our main three properties. And the power property says this: if you have the log base b of something raised to a power, you can actually take this power and move it down front. And it becomes n times log base b of m. And that's a pretty weird rule, but you can do that. Let's do it backwards. If a number is down front, you can actually move it back up to the exponent. So 5 times log base 4 of 2 can be written as log base 4 of 2, and you can move that 5 up to an exponent. And that would be log base 4 of 2 to the 5th, which is 32. The 7 can be moved back up to an exponent. That'd be log base 2 of x to the 7th power. This would be log base 10 of 8 to the 1/3 power, and we can clean that up. Reminder, a 1/3 power is the same thing as a third root, so that'd be the log of 2. Number 16, we're going the other direction with it, expand using the power property. So it says if you have log base 2 of 8 to the 7th power, that 7 can be moved down front. Now let's clean this up a little bit. That'd be 7 times log base 2 of 8. That's 2 to what power is 8? That'd be 7 times 2 times 2 times 2 is 8, so that'd be 7 times 3. So this whole thing cleans up to 21. Okay, number 17. This exponent, again, they want us to use it to bring it down front. I've already got a 3 down there, though. So I'm going to bring down there with it the x minus 1. We can bring it out front times the log of 4. And I could distribute that, and that would be 3x minus 3. And I'm going to leave it in parentheses because the whole thing is being raised, or is the exponent. So therefore, the whole thing is being multiplied by the log of 4. Then finally, this w, it's a square root of w. A square root is the same thing as a 1/2 power. So therefore, that'd be the log base 7 of w to the 1/2, and then that 1/2 can be brought down front. Okay, starting with 19, we're going to put it all together. We're going to rewrite all of these as a single log. We're going to condense them. So let's see if we can remember all of our rules, all 3 of our rules now. Anytime there's a number out front, it can be brought up to an exponent. So we can write this as log of 6 to the 2nd minus the log of 9, and 6 to the 2nd can be a 36. So you have log of 36 minus the log of 9. Now your quotient rule says that if you have 2 logs being subtracted, you can rewrite it with division. So this whole thing cleans up to log of 4. Number 20. All numbers out front can be brought up to the exponents. So that'd be the log base 4 of a to the 4th plus log base 4 of b to the 2nd. Anytime you have the sum of logs, you can combine them using multiplication. So that'd be the log base 4 of a to the 4th times b to the 2nd. Number 21. All numbers out front can be brought up to the exponents. That's log base 4 of u to the 7th minus log base 4 of v. Now you've already got a 2 up there, so when you bring it up here, you're going to raise that to the 3rd power. A power to power, you're going to have to multiply those powers. Now you have the difference of a log. So a difference we're going to rewrite as a quotient. That'd be u to the 7th over v to the 6th. Number 22. No numbers out front, so we're going to combine these two at a time. A log plus a log can be rewritten with a product, so that'd be log base 2 of 15 times 4 is 60. I'm just going to bring down this next part. The difference of two logs can be combined using a quotient, so this would be 60 over 6, which is just 10. So this whole thing is log base 2 of 10. 23, every number down front can be brought up to an exponent. So right here, instead of rewriting the whole thing, I could just do a 1/2 power up here. So you now have log base 3 of 4 plus log base 3 of y plus log base 3, 49 to the 1/2 power. That's the same thing as a square root of 49, which is 7. All of these are being added. So we can go ahead in one step and combine these into 4 times y times 7, which is a 28y. Okay, number 24. We've got a couple of options here. We can distribute the 1/3. I would much rather leave the 1/3 and let's combine the addition on the inside. So that'd be log base 5. To add two logs, you multiply the arguments. So 8 times 27 gives you 216. And then you have minus log base 5 of 3. Now these parentheses are really not necessary anymore because it's 1/3 times that. We can now bring the 1/3 up to an exponent. So you have log base 5 of 216 to the 1/3. That's the third root of 216, which we actually know is 6. So you have log base 5 of 6 minus log base 5 of 3. To subtract two logs, you combine them with division. 6 over 3, which would be 2. Okay, number 25. Every number out front can be brought up to an exponent. This is log base 2 of 4 to the 3rd. 4 times 4 times 4 is 64. Minus log base 2 of 32. We can combine subtraction, a log minus a log, by writing it as 64 over 32. And we can reduce that. That would be 64 divided by 32 gives you just plain 2. And we could actually go a step further with this, because now we can ask ourselves 2 to what power gives me 2? And this whole thing cleans up to just plain 1. 26, again, every exponent I'm moving, or every coefficient I'm moving up to an exponent. So the 1/4 moves up here. And I now have log of 6 squared, which is 36, minus the log of 16 to the 1/4. Again, that's the 4th root of 16, which will be 2, and then plus the log of 3. To subtract two logs, you're going to take and divide and do 36 divided by 2, which is 18, plus the log of 3. To add two logs together, you take 18 and 3 and you multiply, and it gives you the log of 54. Now the next one, we're doing the exact same thing but backwards. We're expanding logarithms. We're going to write these as separate logarithms. Like here you have a product. We're just doing these problems forwards and backwards to make sure we understand. All three of these things are being multiplied, so that'd be log base 6 of x plus log base 6 of y plus the log base 6 of z to the 4th. Now the only other thing that we can do is anytime we have an exponent, that exponent can be moved down front and changed to multiplication, and that is it. Number 28. You have a log of two things being divided, so the log of a quotient, so that'd be log base 4 of the top minus log base 4 of the bottom. If you have something to an exponent, that exponent can be brought down front and multiplied by the whole log, and that's your expanded form. Number 29. What I would do here is probably go ahead and raise all the stuff to the 2nd power, so that's going to be log base 7 of q to the 8th times r to the 4th. I went ahead and raised them both to the 2nd. The product we can split up into log base 7 of q to the 8th plus log base 7 of r to the 4th. And then those exponents, the 8 and the 4, can be moved back down front. Now I'm just going to show you another way of working this. What if I'd have left the 2 up there? Just to show you that it's weird, but the rules of logs actually work with the rules of exponents. we could have brought this down front to begin with and wrote this as 2 times the log base 7 of q to the 4th times r to the 2nd. We could then have split it into log base 7 of q to the 4th plus log base 7 of r to the 2nd. This 4 and this 2 could then be moved down front. And then when you distribute this 2 back out to it, you would get the exact same answer that we got before. Number 30. I would do the same thing. I would go ahead and raise the stuff in the parentheses to the 2nd power, so that'd give it a y squared and a z to the 10th. So now you have a quotient that'd be log base 2 of the top minus log base 2 of the bottom. And those exponents are then brought down front. That'd be 2 times the log base 2 of y minus 10 times the log base 2 of z. Number 31, you have a square root. So the first thing we need to do is write that as an exponent. This would be the log of 7x to the 3rd written to the 1/2 power. And again, if you would like to, you could raise both of those to the 1/2 power, and we can do equals the log of 7 to the 1/2 times x to the 3/2. When I do 3 times 1/2, I get 3/2. Split it with addition. The log of a product is the log of 7 to the 1/2 plus the log of x to the 3/2. Now your exponents can be brought back down front. The 1/2 could be written down here. The 3/2 can be written out there. Number 32. A 4th root is a 1/4 power. So this is log base 3. Let's first rewrite it as m to the 5th, n to the 2nd to the 1/4 power. I would definitely go ahead and raise both of those to the 1/4 power to clean it up. That'd be log base 3 of m to the 5/4 when you multiply 5 times 1/4, and n to the 2/4 when you multiply 2 times 1/4. Now 2/4 reduced is 1/2. So now let's split it. That's going to be log base 3 of m to the 5/4 plus, I'm going to leave myself some space so I can just move my exponents down, log base 3 of n to the 1/2. And both exponents, the 5/4 can be moved down and multiplied, and the 1/2 can be moved down and multiplied as well.